All right, today we're going to be looking at the hypergeometric probability distribution. 6.4, we got three objectives. Determine whether an experiment is a hypergeometric experiment. We're going to compute the probabilities of hypergeometric experiment, and then we're going to compute the mean and standard deviation of a hypergeometric random variable. All right, so the first objective is here. So you got a description of the hypergeometric distribution, and then the criteria. So this is going to be the important part. So you're looking for a finite population that has a big N, so capital N elements, so some number that we know. We're going to, for each trial, the experiment, there are two possible outcomes, success or failure. There are exactly K successes in the population, so we're going to call that special K. There's going to be a group of interest. And then 3, a sample of size little n is obtained from the population of size n without replacement. So those are going to be the criteria. And then these are the notations that are going to be used. So the population size is the capital N, the sample size is the lowercase n. There are K successes in the population, and the random variable X is going to denote the number of success in the sample size of n, and X must be greater than or equal to the larger of 0 or n. I'm sorry, this n minus the product of n minus k, and X must be less than or equal to or smaller, the smaller of n or k. So it reads hard to read, but you'll get to see what it means when we start solving problems. So they give you an example, give you some numbers, they show you how to denote each of those, and then objective 2, compute the probability. This is the formula. I do believe we will be able to input each of our parameters, n, k, big and capital, uppercase n and lowercase n, K and X. We'll be able to put those parameters into StatCrunch and compute the probabilities of what we want. Here's an example done by hand. I'm using combinations. That's what the C is. And then they talk about doing it with technology. So we'll do most of the time. And then computing the mean and standard deviation. So these will be some formulas that we'll need to definitely pay attention to. The mean of the hypergeometric is n, the sample size, times k divided by big N. And then the standard deviation, this a little bit bigger of a formula, is the square root of big N minus little n over big N minus 1. So you take that population minus 1, divide those two, you multiply that by n, and then you multiply that by k over n, which is the mean. So you can kind of think the mean is kind of ingrained in the standard deviation. And then after that, you multiply by n minus k over n. Here's an example of them showing, computing the mean and the standard deviation. And then here are some steps to do it with technology, and StatCrunch is what we're going to be using. So you're going to do stat, calculators, hypergeometric. We'll enter those parameters. Okay. So they're telling you the sample size is going to be denoted by n. Sorry, the population is n. The sample size is going to be m. So they've changed it. Instead of n, big N, and little n, they have n and m. And then the number of success is going to be k. And then the probability X. All right, let's jump over to MATLAB.